Come one, come all. All right, attendees, as you guys start to flow in here, we're going to give it a couple minutes for you guys to rank and file before we get started here. We hope all of you are enjoying your Thursdays and have good plans for the weekend. Please, as you come in, make yourself familiar with some of the buttons at the bottom. The chat function you will see where our wonderful association host, Emily, will be providing you with some of the high-level information. As people are winding in, we want to make sure we delineate the difference. So if you have a question for one of the things that Kevin is saying, to the right of the share green arrow or to the center share button on Zoom is the Q&A button. Please submit your questions to the Q&A button, not into the chat. If you submit into the chat, we will find you and dock you 3 NAFA points. Okay. I think our attendees has peaked, so I think if everybody's about ready, we'll kind of start this off and let people know that if there will be a recording of it available. So if you do jump in a little bit late and you missed the first couple minutes, you can kind of double back and catch the wonderful introduction we're going to give Kevin. So Emily, do you want to start us off with some high level stuff before we kick into the introduction?
Okay. Sorry, I couldn't get myself off mute. Welcome everybody. I'm so glad to see you here this afternoon. My name is Emily Bardash. I am the Executive Director of NAFA, we're pleased to have everybody here today. So today's webinar is best practices for on-site best practices for on-site air filtration, what every technician and facility leader should know. Before we get totally kicked off, just want to remind you that NAFA is your source for education and best practices in air filtration. So we've got a couple of conferences every year. We have our annual convention, which is going to take place in Newport, Rhode Island in October. This is really for business owners where we focus on the business, not so much in the business. It's an opportunity to come see everybody and even bring a spouse. We also have our technical seminar, which is going to be in 2026 in Louisville, Kentucky. And this is really much higher content. Sales folks come as well as engineers, as well as the owners. I hope most of you are aware of our best practice guidelines, which are a practical way to apply a standard. So I guess ASHRAE creates the standards and NAFA helps you apply them. And we're going to talk about one of them today. These are free on our website. Also, and if you are a customer facing and on the distributor side, associate yourself with these guidelines. You can have them branded and you can leave them behind as an educational tool for your customer. So you can also find us on social media and we have a podcast. So please consider us when you're looking for education in air filtration. So just hand it back over to you, Ian, to introduce our speaker today.
Perfect. Well, first I will host and I will try to moderate. To say I am close to Kevin's level is a vast understatement. I'm Ian with Research Products, and let me be the one to introduce you to our friendly neighbor to the north. To many, he needs no introduction. We have with us one of the Graham Poombas, I would say, of the air filtration industry, Mr. Kevin Delahunt. So Kevin has over 40 years experience. And he is kind of the definition of what we would consider a certified air filtration specialist. Kevin literally is like the certified air filtration specialist. A little bit about him. He's a life member of ASHRAE, also BOA of Canada. He's formerly on the board with NAFA. He was formerly on the board of BOA, former chair of the guidelines committee. So that's one of the reasons you'll see a very easy to understand, succinct summary of kind of the guidelines and the importance of the guidelines, Kevin being the former chair. And, you know, a lot of times I think when we say such and such person wrote the book on something, I think when we say that about Kevin, he literally did write the book on the guidelines. So without further ado, Mr. Kevin Delahunt.
Thank you, Ian, for the introduction. I want to just say right up top, I started when I was 12. That's how I got 40 years into the business. So anyway, a little bit about BGE. BGE is a Western Canadian headquarter company in Edmonton. We manufacture, service, supply filtration products. Just going to move this out of the way here if I can. Sorry about that. We have, I apologize for this. I'm just trying to get this, this organized here. Okay, there we go. 18 NAFA certified air filtration specialists, CAFS, 20 NAFA and NADCA certified technicians. And I want to talk about a bit about this because the guideline actually, if you read the guideline, it's part of the process along with the manual to gain your NCT certification. And we recently acquired a company that does testing of biosafety cabinets and clean spaces, and we have over 40 specialists that do that type of work. We are active in a lot of organizations, NAFA being one, ASHRAE, NADCA, BOMA, anywhere where our customers are. NAFA's mission statement is to be the global source for expertise, education, and best practices in air filtration. And I hope with this presentation, you'll get some feel for that, what we're trying to do is promote the industry within the industry. So today it's a best practice guidelines, and I've given, this is, I think, the fourth webinar or talk I've given on the guidelines. The other three that I wrote, commercial and residential being two of them. And it's, we're really trying to do is just raise awareness again on the aspect of air filtration, servicing, installation, supply, that type of thing. So just bring again the level of service up to a point where it's considered, you know, more of a profession than just last guy on site to do that. So the purpose of the best practice is to provide comprehensive guidance for the inspection, servicing, replacement, and retrofitting of filtration products and systems to the diverse HVAC equipment found in today's built environment. And the benefit to anybody listening to this is that the guidance will enable every company and individual that services air filtration products to perform the work in a consistent, safe, healthy, and environmentally friendly manner. Now, I love this quote from Dr. Allen in his book, Healthy Buildings. The people who manage your building have a greater impact on your health than your doctor. When I first read that, I probably read it about 10 times thinking, wow, that's really amazing. How can that be true? But hopefully when we go through some of this information that we're going to talk about today, we'll get a better understanding of just how important, you know, the people that manage a building, that provide the conditioned air, the filtered air into the space, can provide that healthy environment for the people that live, work, and play in our built environments.
And Kevin, before we move into this part, I want to just emphasize to all the people out there, we have salespeople, we have technicians, we have engineers. If you are a person that is responsible for the air quality or air quality products in your space, we really emphasize these guidelines, paying attention, making notes, and submitting questions. So it is super important to continue on with what Kevin's saying. But if you're a person that touches air quality in any form, this is the part for you.
Okay, and before we get into the nuts and bolts of the guideline, I'm going to talk just some background on, you know, filtration. So when I was putting this together, I was thinking, well, if I was just starting in a company and my job was to go out and change filters, my first question may be, so what's the big deal? Why is filtration so important? When we think about it, And I'm going to make a confession right now. I am a filter nerd. I do read a heck of a lot of anything that comes across my desk in regards to indoor air quality, filtration, ventilation, you name it, I read it. And this comment is in 99% of the information that I read, whether it's a university document or just an article in a newspaper or a magazine, but everyone, usually within the first paragraph or second paragraph, says, oh, we spend 90% of our time in the indoor environment, which is true when you think about it. Your house, you go to work, you're in your car. We're in a space that we're not actually outdoors. But what I like to say is that I turn this around. I say, well, okay, 90% of our time indoor, what really we should be talking about is 90% of all the air we breathe has been conditioned and filtered. So you think about that everything that you're breathing has gone through some sort of system. And then your question should be, well, how well would you like your air filtered or conditioned? What quality of air would you like in your space? And the interesting thing is that in regards to like air in a space, we heat, cool, humidify, dehumidify, ventilate, and filter air before it gets into a space. The first ones, I can feel heat. I know if a place is warm or cool or humidified or dehumidified. Even ventilation I can feel. But in a lot of cases, the filtration and the quality of the air, the filtered air, we don't have a good feel for that, because you just can't visually see it. So the next question would be, well, so what? Why do we filter the air? We provide clean air for the health and safety of really four things: people, places, processes, and products. And probably the most important is people. We try to remove particulate and gaseous contaminants from coming into a space because you have really two situations: acute short-term effects like headache, nose and throat inflammation, coughing, pneumonia, and skin irritation, which you usually overcome after a period of time. But in some cases, if you're impacted by long-term pollution or poor indoor air quality, you get a chronic or long-term effects, which can vastly affect your cardiovascular system, your respiratory systems, and impact organs in your body, even to the point of premature death. So places, I think about, systems, air handling systems and buildings and what have you. And the consequences to poor air quality or poor filtration is that we reduce the efficiency of the system because we're clogging coils. We're not removing the particulate before it gets on the fan, the motors, and what have you. And system overload. We poor indoor air quality of space. We shorten equipment lifespan because it gets dirty or contaminated. And just higher operating costs. It usually costs more energy to try to pull air through a clogged coil, obviously, than a coil is a clean coil. And I like to say, if the filter's not filtering, something else becomes a filter, and sometimes it's your coil or your fan or other parts of the mechanical system, your ductwork, and it shouldn't be. And processes. There's many processes that require certain levels of filtration that are necessary to provide the end product. And you think about, data centers, even an operating room, which could be considered a process in doing the work, and a product in the person that's lying on that table. There's the finished product. Was the surgery successful? Well, if you open a body to the atmosphere, you want to make sure that you're not providing a level of contamination that might affect the results of that operation. And lastly, products. If you think about you getting your car painted, I don't know how many people have actually seen a paint booth where the car is driven in and painted, or even, maybe off an assembly line, but they're very sophisticated, almost clean spaces now, with the ceiling in some cases fully filtered, and providing a level of air that are not going to have, a dirt particle land on a paint job and you have to redo the paint job. So I think that's probably why, I don't know what A new paint job on a car costs, but it's probably in the thousands of dollars now. Pharmaceuticals and the food industry all require, in many cases, sterile air, void of any particulate that might contaminate the end product. So those are basically the 4 reasons why we filter the air. Now, moving on, there are 2 equal and complementary comments when delivering filtered air. And I say this, man, drives me crazy, but way more attention is given to the filter product than the service and installation. And I say this right from design and right from, installation of rooftop units. There's all kinds of thought giving in the type of product that we're going to put in there, but not much in the hardware that the filter sits in and has to provide that level of quality. And one without the other just does not provide the level of air quality as designed. If you design a MERV 13, MERV 14, MERV 15 system, you need the filter hardware, the installation to match that level of performance. And I'll tell you right now, in our industry, it doesn't. We don't give the level of attention that we need to the equipment. And as our founder said, if it doesn't fit, it doesn't filter. It's pretty basic, but that's true. All the air needs to go through the filter. And right now I can look at 100 air handling systems and probably find leakage in 99, maybe even the 100.
Kevin, you highlight a really good point that I think we want to emphasize. Whether you're an engineer, a salesperson, a technical person in terms of a technician, the understanding of what your customers, to your point about the filter product, make sure you understand what the filter product that you're selling or providing is doing downstream. I think a lot of times, to echo your point, Kevin, is we sell the product or we get the product from our manufacturers to the end users, and then we kind of forget about the install, the design application. So even if you're one of those people who, my company doesn't do service, you still have to understand the process, because at some point in the world of filtration, this type of information will be pertinent to you, and you will come across it. So we really have to pay attention to Kevin's second point about what is happening to the filter products once they leave our facilities.
Yeah, and good point, because the filter product is labeled. If I buy a MERV 13 filter, it says MERV 13 on it. But if I go up to the air handling system, it doesn't say this is a MERV 13 filter system. And that's where we need to go as an industry. We have to, and I'll talk a little bit more about that, but we want to guarantee that air that leaves that system, which is the filter product and the hardware, meets MERV 13, not MERV 7 or MERV 8. Air enters a building in 3 ways. It comes through mechanical air exchange through an air handling system, infiltration or exfiltration through cracks and windows and what have you, and then natural air exchange that might be moving through open windows and doors. Mechanical filtration, the one path, again, that operations can control is the quality of the air being supplied via the mechanical route. And again, I think this is where Dr. Allen was emphasizing the important point that the people that operate your building, have more control over your health than your doctor. They do have a say in the quality of the air delivering that space. And I like to say it is manageable. We can control it. This is source control. The air is coming into your space. This is where you want to remove particulates and gases, contaminants from coming into the occupied space. You can do it at this. It's really hard once it's in your space. We use the term fresh air in the industry, and I was just reading an article just before I got on today, and a PhD talking about what you needed for indoor air quality. He said, bring in fresh air. Well, when I think about fresh air, I think, okay, you got, mom and her daughter looks like riding a bike along a bike path next to a lake or a reservoir, and that looks pretty good. But when I back out, I look at, this is an 8-lane highway. They're 10 feet away. How fresh is that air now? And when I pan even further out, I look in the background and see 3, 6 smokestacks, from an industrial complex that is sending whatever out, and depending on the way the wind blows, how fresh is that air? So really, as an industry, we got to throw that term right out the window, literally. The air that we bring in to any building as fresh air is really outside air with all the impurities associated with it. And I'm not sure where we get fresh air anymore. And it's a subjective term. So what does it actually mean? At what level do you say, well, this is fresh, it only has X amount of carbon monoxide or carbon dioxide or NOx or particulate in it? I don't know. We need to use outside air, not fresh air. And outdoor contaminants, well, we saw that with the last picture, like you have vehicles, you have, industrial complexes, agriculture, all giving off contaminants, nitrous dioxide, ozone, sulfur dioxide, particulates, all coming from, a myriad of other facilities and operations. And this is that large soup mix of contamination into the air, and that buildings are bringing in, again, as their outside air, not fresh air.
Kevin,
And
before we move
ahead.
off of section 3, we had one of the questions submitted in advance that I think pertains to this topic. One of the current buzzwords in the industry is the outdoor air exchanges, or the ACHs. Dr. Allen talked a little bit about it at our seminar as well. So the question is, are air exchanges one of the most important ways to assure a better environment?
It's definitely, top of the list. I like to say, in one of the slides I used in another presentation is filtered ventilation, using filtered as an adjective to the ventilation, because we need to bring air in the building. We need to bring a lot of air into the building. And the more air that we bring in the building, the better we flush out the contamination. Now, the issue I have, and as we look at this slide, this is a picture of downtown Calgary. And you look at the buildings, and we're not as congested as some of the major cities in the United States, the Chicago and New York and Boston and that type of thing. But each of these buildings are bringing hundreds and hundreds of thousands of CFM every minute, or cubic feet of air every minute. But they're also exhausting the same amount, which means they're exhausting their kitchen exhaust, their parquet exhaust, their bathroom exhaust. So what's to say that the building that's only 200 feet next to it is not intaking that as, again, their outside air? Well, they are. We're just exchanging air almost between buildings. So if I do, whenever I'm cooking, I was going to say using the washroom in the building in the forefront here, the guy next door, that might be their outside air. So again, it brings that whole aspect of the fresh air into context too. How fresh is that air? Not very fresh. So, but ventilation, very important. And I think back to a lot of schools. I do a lot of talks in schools and that sort of thing. And we don't bring in enough air into a lot of facilities. And we're trying to increase that. And ASHRAE has been, I guess, the driver in some regards, but also limiting the amount of air coming into a building due to, trying to save energy at one point in time. You're going to spend energy when you bring air into a building, but we also know the benefits of bringing more air into a building. Reduce absenteeism, increase productivity, all kinds of good things happen when you bring air. But you filter it, even better things happen.
Yeah, Kevin, and I think we've seen a great uptick in the outside air influence in our air quality, especially since a lot of the standards that were from 40 and 50 years ago are now being reversed in this modern day outside air IAQ segment. So thank you for that question. And if anyone else has any other questions, make sure use the Q&A button at the bottom, plug them in, and we'll make sure they get answered. So,
yeah, good
thanks,
point,
Kevin.
Ian. Yeah. Air is contaminated by outdoor and indoor sources. So we know what's coming in some cases from the outdoor, but we also generate a lot of particulate and gases indoors. So you can't guarantee quality indoor air without looking at the sources of contaminations that are generated within the space. So, and those can be, think of, copiers and, kitchens and, just people cleaning solutions, all kinds of things, carpeting, generate a lot of particulate and a lot of chemicals within the occupied space. But the biggest contributor to contamination in the building is people. You add more people to a space, you're going to increase the particulate load and odor and gaseous contamination. And the picture on the left, obviously, is a concert. The amount of air exchanges they're going to need to provide a comfortable level of air quality is probably 20 or 30, like virtually changing that air every 3 to 4 minutes. And if you don't, it becomes pretty stale in there pretty quick. And even in the most controlled environment, people are the most significant source of contamination. We saw a picture back there in the operating room where, people are completely gowned up now, mask and everything, to try to eliminate any off-gassing of particulate or gases from the people that are actually working in the space. So particles, because size does matter. And PM 2.5 is really the target particle size, and it really became well known during COVID when it was identified that the COVID virus was in that size range of PM 2.5. So all of a sudden it was, how do we stop PM 2.5? Well, the thing is, we can't see PM 2.5. And even on this slide, I look at it and say, well, it looks pretty big on this slide. But everyone's sitting there, if you've got a pen in your hand or a pencil and you look at the point of the pen or pencil, and at that point, you can probably put about 100, 200 PM 2.5 size microns on the point of that pen. These are really, really small. We can't see them. And we really have no end. It goes back to that thought about, I can feel heat, I can feel cool, I can feel ventilation. I have a good understanding if it's humidified or dehumidified in the space, but I really don't have an idea of just what the air quality is in space, specifically for PM 2.5, without doing some sort of monitoring or testing in space. So size matters. If I could count up all the particulate that are in the air right now, 99% are 2.5 microns and smaller. And these cause all kinds of health impacts that we already discussed, and filter challenges, because it's a hard particle to stop effectively. It can be stopped effectively, but you need, again, a quality filter and quality installation. So with this, we look at here, PM 2.5, everything to the left of that is in that PM 2.5 micron size range. So you got bacteria and viruses and suspended atmospheric dust, wildfire smoke, which is prevalent today in the last many years here in the Western North America, smog, tobacco smoke, soot, what have you. Oh. And particles don't settle out of the air like you think they would. When we think of a particle, we think of the dirt that lands on a surface, and you wipe it down with a cloth and say, oh, I cleaned up the place really good. But if we look at PM 2.5 micron size particles and just the size and where they sit in here, again, and everything to the left, if I had a 2.5 micron size particle and I actually put it in my hand and dropped it, it would virtually stay airborne indefinitely. It doesn't settle. So it's, again, we can't see it and it doesn't settle. So it's almost out of sight, out of mind. We really need to get, way better at monitoring these things, and that's one thing I'm going to discuss. So size is important, but concentration is a killer. I said we can't see PM 2.5 micron size particles, but this is downtown Edmonton, Alberta, Canada, August 15, 2018, at about 11 o'clock in the morning. Those are PM 2.5 micron size particles. There's so many of them that it now almost looks like a smog. This is wildfire smoke that's descended on the city. And this is, again, the outside air, that fresh air that we're bringing into the space. How fresh is that air? Not very fresh. And just to give you an idea, this is the same time of day in December, what's that, about 5 or 6 months later. This is a typical view of downtown Edmonton. Go Oilers. And you get an idea that the air quality is a little bit different on, and better on that day. So I go back to that other slide. These buildings all still need to bring in their ventilation. They need to get the air into the building, provide pressurization. You can't just turn everything off. You need to bring some air into the space. That's the air they're bringing in, again, as outside air. And just to further the fact, I just took this off the web today. This is a wildfire smoke in northern Manitoba. Go Jets. And as you can see, this is just the sheer amount of contamination that's created, depending on where the which direction the wind's blowing. It's hard to say who's going to end up with this, and it can be hundreds and thousands of miles away where the smoke and soot can end up. So definitely an issue. And like I say, now our 5th season. Minimum efficiency reporting value, as put together by ASHRAE, coming from their ASHRAE standard 52.2. And ASHRAE standard 62.2 talks about minimum air filtration of MERV 8. And if we look at MERV 8 is just, I'll put my plug in right now, not capable of removing that PM 2.5 micron size particle. It's just not good enough to do that. We need to get into the MERV 13 to 16 range to start identifying and reducing that at a substantial rate. So, okay, that's the sort of the review of air filtration. Now we're going to talk about, I guess, the technicians on site, the actual document. And we put this document together again, and a lot of it has, I took or stole directly from the BG service protocols that we have to put together. We do a lot of work for, large industrial complexes, and they're very stringent on safety protocol and documentation. So when we start a contract, the first thing we do is go to the site and do a pre-site assessment. And the pre-site assessment, first we start as we look at, is a hazard assessment required prior to site visit? Is the area we're going in hazardous? The air quality or the air in that building hazardous? And are there permits required for the shutdown of the equipment and access to the service unit? In many cases, we need a permit just to go change some filters. Commercially and light industrially, no, but in large complexes, and even in a hospital, you would need a permit to shut down a piece of air handling equipment. Next, you have, is the work area confined space, and do special precautions need to be considered? Well, if you're in the industry, you have a pretty good idea that the mechanical room isn't exactly built for the people that have to work on the equipment. I think you could agree with that. I'm always surprised when I go in and find, copious amounts of room to work on a piece of equipment, because usually everything is pretty tight. And if it isn't tight, someone looks at the space and say, oh, look, more storage space. That's great. And is there adequate lighting? Are you able to get into the unit and actually see what you're going to work on? In a lot of cases, that's not available either. So you need to make note of that. In some cases, you need to bring additional lighting into the space. Are there special tool requirements to open a unit or to work on that unit? And are filters easily accessible and can be performed in a safe manner? In some cases, units are elevated in the ceiling and you need man lift, scissor lift, or ladder or whatever to access that unit. You need to make note of this and put it on your pre-site assessment. You're required a pull stick. Sometimes we can't get at there's only one door in a unit and we need to reach in 12, 14, 16 feet. So you need something to actually pull the filter out. The ladder, as we talked about, sometimes a scissor lift. And you have the correct size and types of filters required to complete the change. In a lot of cases, these are rooftop units. Do they have a roof hatch? Or do you have to lift the filters up over the side of the building? Do you have a pulley system to lift them up? they're not easy accessible in a lot of cases. And these all need to be written down so that you have that documentation when the service people go do the work. Personal protection equipment is required for site. Many places we go to now, we need all this. We need a head protection like a hard hat. We need hearing protection because you're in an industrial complex that has a lot of background noise. Eye protection and respiratory protection. And there was one question that came in regarding respiratory protection. Most important, N95 mask, or even sometime a half mask or a HEPA mask, it needs to be used. And the reason, and I always say, is that we put filters in to stop the PM 2.5 micron size particle. We take those filters out and dislodge that dirt cake, and sometimes get those particles suspended or resuspended. Do you really want to be working on those and breathing that resuspended air with copious amounts of PM 2.5? No, you don't. Hand protection, wearing gloves. A lot of times we're working around metal that can be sharp, and you can cut yourself. Fall protection in some cases, depending on where the system is. Protecting clothing, sometimes it's fire retardant clothing or really heavy duty, and foot protection, such as steel toe boots. You should consider a safe work practice. If you're going to go into this business or are in this business, every job that you perform should have a safe work practice where you write out the purpose of the work, you identify potential hazards, what required PPE is needed to complete the job, and what training requirements are needed to do the job. And then any other notes that are specific to that unit. Do we have to, contact security or notify somebody we shut a system down? Once we do the pre-site assessment, and that keeps, as part of the protocol for doing the service, we now are on site doing the work. So we check in with security first thing, tell them we're on site, contact operations personnel regarding permits or shutting down equipment. We avoid working with fans running. There are rare circumstances where this may happen, but a hazard assessment needs to be performed before the work starts. And the service technician has the final approval on whether it is safe to proceed. If he doesn't feel safe, he should not proceed with the work. And lockout tagouts of the equipment during shutdown use your own lock so that someone else can't come and start the unit up while maybe you're inside it and get locked inside. So replacement procedure, we place the filters to be replaced close to the unit being serviced. For pre-filter replacement, we carefully remove the filters to limit particulate offloading. As I mentioned, we don't want to resuspend that dirt back into the air if we can help it. So we remove row by row, top to bottom. When replacing pad filters, we minimize the offloading dirt by carefully rolling the pads up. And we place the spent filters immediately in a garbage bag, sealed and ready for disposal. On-site completion procedure, we brush and vacuum frames and plant them upstream and downstream of the filter bank, if accessible, not always. We install new pre-filters in the same size and efficiency, and remove all tags and locks if applicable. Remove all garbage disposal bins and remove from site. For secondary replacement, we follow the same pre-filter replacement procedures, removing the secondary filters, limiting particulate offloading. And again, I can't stress the importance of trying to do this in a manner that doesn't dislodge the dirt cake and resuspend dirt back into the air, into the breathing zone of the people that are doing the changes, or back into the new filters that you're just ready to install. We replace the secondary filters, the spent ones in the original box, seal and remove for disposal. And before installing new secondary filters, we brush and vacuum the filter frames and plant an upstream, downstream of the filter bank, again, if accessible. Last thing that we tend to do is look at the system again to look for any deficiencies. Where's their bypass? And in the pictures on the right, you get an idea that in the top left-hand corner, you got a filter that's it's probably $100 cartridge filter that's fell out of the tracking because the tracking, again, wasn't sufficient enough to hold the filter in place. It's either got weak or separated over time, or was just never the right dimension. So you got a system where you're paying maybe $100 a filter, it's now acting like a $10 filter system. And in the other ones, you can just see, deficiencies and bypass, where filters didn't come from door to door and completely seal off that opening. Again, with the goal being all the air to go through the filters. So we look for bypass, using a flashlight sometimes to see the any gaps between the frames or the filters. Are any systems or frames bent or broken, gates missing spacers. In the upper right-hand corner, they normally would have put a metal spacer or a piece of wood spacer. Ideally, it's better to slide it to the far end and leave it there permanently. But in this case, it was probably got missed or replaced, and they just ended up cutting a filter to fit that open space. Again, not the best way to do it, but that's the design we have to deal with in a lot of cases. Like, go figure. And magnet gauge is not working. Let's get those working if we can. So on-site completion, we inspect the filter bank for overall structure integrity. Does it still, if you put any pressure on that bank, is it moving back and forth and breaking down and going to cause some bypass? Look at clips again. Make sure all the filters are the same size and efficiency. We remove the tags and locks if applicable and restart unit. And validate system efficiency, sign and date a status card. It's always good to have some sort of documentation at the unit that shows when the filter was changed last. Frames, these are frames. Is that system solid over time? Duct tape works wonders at sealing short-term bypass situations between, especially cardboard filters. We tend now to use weather stripping and gasket seal right on the filter as opposed to on the metal frames. And lastly, the service card is unavailable if you don't have one. Sign off work permit, complete all necessary paperwork, remove everything to garbage and disposal bins, and notify operations staff upon completion of work and any deficiencies that you might have seen during your service time. Bottom line, the goal of every filtration system needs to be system efficiency, not just filter efficiency. If you buy a MERV 13 filter, your system should be a MERV 13 system efficiency. And in most cases, it's not. And that's unfortunate. Lastly, take a look at NAFA's certified NAFA certified technician, the NCT program. It's very good at training technicians on all the aspects, many more than I even discussed here today, in changing and servicing filtration products in the field. Look at them on the NAFA website, nafahq.org, or contact a NAFA member to help you get educated and certified. Program well worth checking into.
And Kevin, one of the things I think, just to kind of put a bow on your talk about the importance of service technicians, is for a lot of our customers and a lot of the engineers, the amount of money that gets spent on the filtration systems and how much importance needs to go into the checklist and making sure that all the I's are dotted and T's are crossed. I think there's probably a lot of people out there that could tell stories of woe about a technician driving all the way to a job site and finding out, X, Y, or Z, or this part wasn't done, and having to sit an hour and a half long training session because it wasn't completed beforehand. So a lot of this is very important from a cost saving standpoint, which is generally tends to be the number one factor that we see in the field. And in the same sense, if you are out at a customer and you see somebody that's doing things right, things that are done modeled to the way Kevin explained it, NAFA has put out these clean air awards. So I know we're going to talk a little bit more about plugging kind of the things we do with NAFA, but if you have a customer that's dotting the I's and crossing the T's, let's make sure we get those nominations in for the clean air awards, because at the end of the day, a customer that's being wise with their filter products choices, their filter service choices, that's a customer who's ultimately probably saving the most of money and then also has the highest quality of air in their system.
Well said.
So,
And
well,
again,
we do have one
yeah.
question, Kevin, I have to put to you real quick.
Well, I got one
So-
comment first. I'll just end with this
please.
comment, is that this work is not the most glamorous job on the planet. And it's usually given to the last person in a building, and it's usually the apprentice. And what we need to do is just raise the professionalism in this. If we want to improve air quality in the space, we need better attention to detail in the servicing and supplying. The filter product's really easy to buy. The servicing is really hard. I'll end with that.
Absolutely. One of the things you talked about, Kevin, and I want to circle back on it is, one of the questions we had was, what are some of the long-term effects of heavy particulate exposure often faced by installation crews? And then let's highlight the importance of PPE and prevention there.
Well, again, it's, and I see a lot of people, well, not even our neighborhood right now, just starting, the spring cleanup. So I see the guys out there with the leaf blowers and they're blowing crap off the lawns, no mask on. I'm thinking, like, you're an idiot. No difference in changing of filters. We know that when we move a filter out there, we will dislodge some dirt. And it's now a concentration amount of that particulate that we didn't want to breathe in the first place. To go in there without some sort of breathing apparatus, minimum of an N95, well sealed, you're crazy to be doing that, and you're asking for all kinds of trouble. So I can't stress the importance enough. It's very, very important to have breathing apparatus when you're doing this work.
Yeah, I think to point to some of the long-term exposures, go back to the first section of the webinar, we talked about some of the acute PM 2.5. Because yes, as you're cleaning these systems, I mean, I think we've all seen it where a technician will take a filter out and just throw it like a Frisbee, either off the side of the building or, 20 feet away, and they stack them all up because you're up on the ladders. And, to your point, it's not a glamorous position, but how often do all of that dirt that you're taking out of those filters get re-put into the air and then sucked right back into the system as soon as you turn it back on?
Yeah, just short cycles right back into the building. Thank you very much. So it again makes no sense. So we have a much better understanding of, I think, particulate loading and offloading that, and these can be, strenuous protocols to do, but it's really important to do them and have them in place. And the people that are doing the work need to understand the hazards before they go in. We need to make them aware that you just don't go in there without the right PPE and handling of the product.
Yeah, and I would be remiss not to add is now that we're starting to see more of this outside air influence, it is very important for that on-site checklist to make sure you take an inventory of all the filters, whether it be, the metal mesh on the intake filters, whether it's the pre-filters, the final filters, and when your service technicians are out there or your customers out there, make sure they're checking the metals, because as somebody that knows quite a bit about metal filters, the pressure can load on the face of those metal filters so rapidly, and metal filters go from working to blowing out over the course of maybe a week or two. So you want to make sure that you're really checking the intake so you're getting as much air as you can through those metals into the pre-filters, and that the system, and I think you've emphasized this many times, Kevin, the system as a whole is as efficient as possible, because if you let one part of the system slide, it's going to affect the downstream of all the rest of the system.
Absolutely.
All right, we've got a couple Q&As I would like to bring up here. This message is from Cody. When in the field, how would you be able to tell what a system may be rated for? I'm thinking he means if you're a service technician, you're up on the roof and you're looking at, maybe the MERV efficiency of a system. I'll let you take first crack at that, Cody, and if not, or I'm sorry, Kevin, and if not, maybe I can help add a little bit to what Cody's asking here.
So what it's rated, so whether the airflow or the
I'm thinking he's talking about the MERV efficiency.
Okay, in this situation, unless your customer really, how should I put it, we're usually trying to match what was in there before. So if it's a MERV 8, most cases we're going to put a MERV 8 in there. We might suggest that they go higher, but again, under precautions, you always want to, monitor. If you increase the filter efficiency, sometimes they have adverse effects on system operation. So, and that would have an adverse effect on the ventilation. So we don't want to reduce ventilation by increasing filtration. So, to answer that, we would match what's on there in the first place, and with consultation with the owner, operating manager, maybe make a suggestion to increase filter efficiency at that point. But we wouldn't just arbitrarily go in and upgrade a system because we think it should have a higher, maybe a higher MERV rating. I don't know if that answered that question or not, but
yeah. I'll add a little bit to that, because as somebody who's been on site, when we had these customers during COVID that were shifting from MERV 8s to MERV 13s, Cody, the more you understand about the system in terms of how much intake air is coming in, what are the customer expectations, right? I think one of the things in air filtration that's not synonymous is the more expensive the filter is, doesn't necessarily mean the longer it's going to last. I think a lot of customers will buy a MERV 13 hoping that it has the same duration life as, say, a MERV 8, which, as we kind of see from here, that's not necessarily true. So if you do upgrade the efficiency of the system, really monitoring the pressure drop, really monitoring the dust load, will help you come to a kind of a sweet spot where if I move from a MERV 8 to a MERV 11, then I need to change the filters maybe every 6 weeks or maybe every 2 months, as opposed to the original duration that those filters were lasting. And if that doesn't answer your question, always make sure to email either Kevin or myself. Many of the NAFA people are available if you want some more clarification on that one.
And again, I think if we reduce the ventilation, are we any further ahead? We don't. In most cases, like buildings are designed for X amount of air exchanges. If we reduce it by 10% or 20%, I don't know if we're any further ahead. Ventilation is extremely important to a building. So having cleaner, less air is, I don't think we're further ahead in the pursuit to provide a high level of air quality.
Yeah. So Kevin, we have another question here saying, but we did not mention anything about the pressure drops and its effects on pre-filters. So I think, Siddhi, I think what you're talking about there is maybe a little bit different of a topic than we were covering here. Obviously, NAFA takes into account pressure drops pretty much with everything we do, especially as Kevin, with over 40 years in the industry, I think he probably knows more about pressure drops and their effects on the system. So I would go maybe head to the NAFA site, take a look at some of the other guidelines, especially, Kevin, I believe you did the residential and commercial one, where it gives a detailed breakdown about how understanding the initial pressure drop. We're starting to see a lot of variable speed systems in the field now. So I ask a lot of times building engineers, what do you change your filters at? And they say, 1 inch on the pressure drop. But they have no idea what the initial pressure drop rating is because it's a variable system that changes the airspeed. So there are a lot of answers and a lot of questions surrounding pressure drops. It's like one of the stigmas of the industry. But specifically for service techs, I think that the goal here might be that if a service tech's on site, and to Kevin's point about the Magnehelic gauges, if the gauges are working correctly and that service technician sees that pressure is ripping at 0.8, almost 1, maybe even 1.5, they need to go back to on their service notes and say, hey, these filters are being left in too long. We're putting too much load on the system. So I think from that standpoint, pressure drops in terms of service would be something that should be part of your inspection checklist. When that service technician came on site, what was the pressure drop when he was there? I don't know, Kevin, if you have anything you want to add to that.
And good point. And in a lot of cases, probably even more back in the day, we would record the pressure drop on that status card that's on the unit or in the documentation that we provide the customer. So it's a important question. The service techs that go in there wouldn't be the ones that would make that decision on changing the frequency or putting in a different filter. It would go back to the account manager or somebody else. So and your point about the Magnehelic gauges, I've seen way more that don't work than do work. So you got to take all that with a grain of salt too. So
that is for sure. So, and we have a little bit of a follow-up question on that topic. So Dave asked, if you have no filter gauge on the unit, what is the protocol for changing frequency for an industrial or commercial, monthly, quarterly, 6 months, a year? So he's basically saying, if you don't have a magnet helix, what's a good way for maybe a service technician to gauge whether that filter is being changed at the right interval or maybe need to increase or decrease?
Yeah, it's a good, tough question. I'll tell you that, because every area is going to be different. Even in, like, I'm looking across North America, where we get snow covered for, 4 or 5 months, where you don't get as high a particulate load as you might in the spring. So saying that nice and convenient every 2 months, every 3 months, we might go 5 months in that winter season, but monthly in the spring and summer. So really you have to look at, a lot more things than just, coming up with a fast rule. There's no fast rules in this. Every area is a little bit different. And you add forest fire smoke to that, it throws everything out the window. So you need to look at your systems, how long are they operating? Are they 24 hours or only, say, 8 or 10 hours? There's a lot of factors that would go into developing a schedule, but you can put together a pretty accurate schedule that's, you're not going to maximize a filter at 100%, but if you change a filter out at, say, 75, 85% of its life cycle, I think you've done pretty well. But you don't want to take it out also at 25 or 30% with still, 60 or 70% life remaining. So look at your units, look at the location, look at the area that you're in, and you could probably come up with a case and build that schedule based on those types of factors.
Yeah, I would add, it sometimes even can be different from the same building, right? I think we've all been in applications where you have air intakes on the 8th floor versus the 40th floor, and the dust loading will be different on each one of them. So it's really about, understanding the filtration, as we said, it as a system, working with the engineers. If you're the engineer, there's always this adage that we have to run filters. And I think, Kevin, you talked about this, about the 85%. There's this adage we need to use up the entire life of a filter. We need to run it to the point of failure before we change it. So if you do have a customer where it's by chance during certain months you don't have as much dust load as you do in other months, it's okay. It's okay to change, a pleated filter, a pre-filter at 50% life. If we look at the energy curve, you'll ultimately find out that due to the relatively low cost of the filter versus the amount that is being charged in energy to run the system, having a nice, steady, consistent, linear change out schedule will ultimately save you money in the long run, as opposed to having to push the systems to the point of failure.
Yeah, and over time you can develop a schedule pretty reasonably that will be fairly consistent. But just coming up with one before, evaluating all the conditions that are out there is very difficult. And you're probably not going to be bang on for every system.
All right, it is 3:58. We did really good in terms of time. Emily, is there anything you want to jump on and add or plug? I think, again, if you have a customer that's doing things right, Clean Air Awards, we want to give them out. We want to make sure we recognize the industry leaders in terms of the people that are prioritizing air quality. So Emily, was there anything that Kevin and I were not smart enough to ask or answer that you'd like to fill in?
No, this is a fantastic discussion. And I just wanted to thank you, Ian, for moderating, and Kevin for being with us today. We always appreciate your knowledge.
My pleasure.
Perfect. Well, everybody enjoy the extra minute that we're giving you back, and go about your day and take your shop vacs out to the site, clean those tracks, and get some clean air filters in those buildings.
Thanks for
coming. Thank you so much.
Thanks, everyone.